Hello again. So with this video, what I want to do is I want to demonstrate, we talked about a solid state phase change and with the iron wire demo. And we talked about that solid state phase change and how it caused that dip in the wire. And so I want to illustrate this a little bit more with some of these tennis ball models. And these have Velcro on them so I can kind of take them apart and stick them together a little bit easier. So remember, at normal temperature, at room temperature, iron has a body center cubic crystalline structure like this. And so these are all, they're being a little lazy, but they are supposed to represent body center cubic. When we heat it up above that certain point, that temperature, I'll have to remember what that one is though, not right at the moment, it goes to face center cubic. And so it goes to face center cubic, and then whenever it cools back down, it switches, it does a solid state phase change, and it goes from this state, face center cubic, back to body center cubic. And that's what causes the dip. And so I hope to show you here how that works. So if we were to look at this of being a piece of wire that is, this long, and it is at normal temperature, and it's made of body center cubic, and it's clocking in at about 65 centimeters long. Okay. So if I take this, and if we do that rearranging that we said, so if we were to heat this up so that it goes from body center cubic to face center cubic, remember you cannot add any atoms from outside, so conservation of mass. And so we're not adding any atoms to this, we're just rearranging the ones that we have. And so this is kind of how it would go, probably looking a lot different inside of there. And so there I got the first one done. Maybe I will do this like fast forward in post-production. See if I have that ability. Maybe I'll have to ask Mr. Morbido. And so now what you can see, and it's not quite all the way put together, but we went from having, first off, a lot more crystal structures. Okay. We're only, from those 4 body center cubic, we're only able to make 2.5 crystals of face center cubic. And so it went from being much bigger to much smaller because we had to use the same amount of atoms. Okay, using the same amount of atoms, things are more compressed. And so this is what happens. It gets hot, and it does this solid state phase change. So we have thermal expansion with the wire. It's getting longer, but then it will shorten because it'll shift from being body center cubic to face center cubic. Then when we shut it off, when we shut off the wire, it will switch back from face center cubic back to body center cubic, and it'll go out to being as long as it was. And so hopefully that shows, so I'll go ahead and set that one up. Again, what I'm hoping for is that in post-production, I'm kind of envisioning in my mind that this will go a little bit faster. So you shouldn't hear me talk and everything. All right, and there we go. Now we have our little body center cubic, and you can see it is much more spread out. And so that wire, when we shut it off in its face center cubic, it'll start to pull in, and then whenever it switches from face center to body center, those atoms can now spread out a little bit more, and you get those longer. It becomes a little bit longer because there are more crystals that can be made. Okay, so hopefully that allows you to kind of visualize this a little bit more. Yeah, that's all I got.